Hi, today I'm going to go through the process of completing the square. So what this process is all about is taking a quadratic in expanded form and turning it into turning point form. Makes it really useful if you want to draw the graph. You can see at a glance what the turning point is. Sometimes we use this process for solving a quadratic as well. But today I'm just going to focus on the actual process itself. So what we're thinking about in order to do this process are our perfect square expansions. So keep in mind that a plus b all squared, if we expand it, comes to a squared plus 2ab plus b squared. And if we have a minus b squared, that expands to a squared minus 2ab plus b squared. Okay, so let's get started on some examples. So the first one here, I've got y equals x squared plus 6x minus 7. So the first thing you want to do is focus on the first two terms, and we're likening that. Now it's a plus here, so I know I'm looking at my first expansion and I'm comparing that to these first two terms. So I know my x is taking the place of the a. So this 6 is made up of the 2b. So to find out what b is, we simply halve it. Now, so that makes half of 6 is 3, obviously, but we don't have the plus 3 squared there. So we want to get that in there so that we have a perfect square. So basically, we just take the 6 and halve it to get 3. So I'll leave that as it is for now. I'm going to write plus 3 squared on there, but I can't just add it in without it affecting this. So I have to counteract it by subtracting it as well. And then I'll tag my minus 7 on the end. So now looking at these first three terms, I have the complete perfect square. So now I'm going to write it in bracket form and go x plus 3 all squared, and then I've just got to simplify this bit at the end. So 3 squared's 9, so minus 9 minus 7, and then our last step is just to finally tidy that up. Minus 9, sorry, minus 7 is minus 16. So there, that one's done. Rightio. Now that one was relatively easy because we had an even number here. This one's a step harder because we've got an odd number. So let's see how this one pans out. So once again, we're just looking at the first two terms. We notice we've got a minus, so we know that we're using this to complete our square. So we're going to keep that as it is, then halve the 9. I'm just going to leave it as a fraction, so I'm going to leave that as 9 on 2. And I'm going to add 9 on 2 squared so that I complete my square, because at the moment I only had those two terms. Now I'm going to counteract that by subtracting it and then tag my plus 10 on the end. So now looking at these three terms here, I now have a perfect square, which I'm going to put in factorized form. So I'm going to write that as x minus 9 on 2 squared, and then simplify this bit. So when we've got a fraction squared, remember we need to square the top and square the bottom. So that's 81 over 4 plus 10. Now to group these together, I'm going to need a common denominator. So I'll multiply the 10 top and bottom by 4. And then I can get my final answer. So x minus 9 on 2 squared. Now minus 81 on 4 plus 40 on 4 gives me minus 41 on 4. And I'll just leave it in fraction form. So that one's done. Now we can see, if we need to, what the turning point is. Now I'm going to take it as one step harder with this example here. So notice now I've got a coefficient other than 1 on my x squared term. So when we do the complete the square process, we really want to get that 2 out of the way. So I'm going to factorize a 2 out of the whole equation to start with. So that'll leave me with x squared minus 5x plus 11 on 2. Now, what we do is just the same process as we did in the last example, but just on this bit here, and the 2 is just going to sit there throughout the whole process. So once again, you're looking at those first 2 terms. We notice it's a minus, but we'll get those there first, then halve this number. So, and I'm going to add on a 5 on 2 squared and counteract it by going minus 5 on 2 squared, and then put on my plus 11 on 2 at the end. So now here, notice we now have our perfect square. So that can be brought into the brackets x minus 5 on 2 all squared, and simplify the last bit. So squaring that fraction, we get 25 on 4, and then we've got plus 11 on 2. Now I'm going to want to group those together. So bringing over a common denominator, again, I'll multiply this time top and bottom by 2. So now the 2 still sits out here. I'll just tidy this one up a little bit. Now we've got minus 25 on 4 plus 22 on 4. So that leaves me with minus 3 on 4. And our last step now is just to take the 2 across both these terms, because we don't want this extra set of brackets here. So 2 times the first bit is just 2x minus 5 on 2 squared minus, now I'll just do the calculation over here to show you where I get my answer. 2 times 3/4, think of that as 2 on 1. And we got a common factor here, 2. 2 into 2 goes 1, 2 into 4 goes 2. So that leaves me with 3 over 2. And that's our final answer. So as you can see, if once you get into the swing of it, if you just stick to that routine of halving this number, adding it on squared, counteract it by subtracting the same thing, and then tagging that extra number on the end and doing the tidy up, you'll soon find the process quite easy. So I hope that's helped you today.